Land Trust, Simsbury Land Trust Education Committee. I want to welcome you all here this afternoon. We're so fortunate to have Connor Hogan here giving us our presentation on old forests. And I just want to highlight a few other events that we have planned for the Education Committee. In November, on the 17th, which is Thursday evening, Mark Scully, who is a resident of Simsbury and a very active member of an organization called PACE, which is the People's Advocate for Clean Energy, is going to address us on his passion to make 100% renewable energy future. No nuclear, no fossil fuel. So that should be interesting. In January, I don't have a firm date yet, but we're going to sponsor a talk about Frederick Law Olmsted, the famous landscape architect. This year actually is his 100th birthday, and he happens to be a native of Hartford, which I did not know. And the speaker will address his life and his influence on landscape design, both here in Hartford and New York City and other places. In February, we are sharing an event with the Simsbury Garden Club, and our own Marjorie Winters is going to speak on the wood wide web. Try to say that 5 times fast. But anyway, so we have some interesting things scheduled here. And in doing a little research about Connor, I found that we shared some connections. We share a Maine connection. Connor is a graduate of Bates College in Lewiston, Maine, and I happen to grow up in Waterville. And we both have an interest in languages, and Connor studied in Nantes, France, during his university years. And we also have a Yale School of Forestry connection. Connor is a graduate of Yale, and my older brother also attended Yale School of Forestry, although a few decades, I think, before Connor was there. But anyway, in emailing back and forth with Connor, I asked him, well, what's the topic of your talk, and what what major points are you going to cover? And he said he's going to speak about, obviously, old forests, and he said our old forests, and talk about old forest dynamics, as well as the future of old forests. And he says he wants to leave the audience informed and empowered on this topic, this timely topic. He is currently director of the McLean Game Refuge. He's a certified Connecticut forester. He has a master's in forestry, and he says, I just love old forests. So thank you and welcome.
Hello, everyone. Thank you for coming out on such a rough afternoon. Well, thank you for the introduction. And yes, today is about old forest, and I should have said our old forest because this is a very Connecticut-specific discussion about forest. I'll begin. I professionally fill three kind of buckets that are pretty distinct in terms of how people engage with the land. And the first is that I'm a conservationist. I am for maintaining the integrity of our ecosystems above other uses. And actually, in that photo, that's with me and an unrecorded ancient yellow birch tree on the north side of Mount Chicorowa in New Hampshire. So there's countless old trees in White Mountain National Forest that no one has ever cataloged. And then I'm a forester, as we just heard about I got my master's in forestry from Yale, and I've been a forester in Connecticut since. And foresters are people who write management plans for a forest, and that could be for wildlife values, that could be for timber values, and that could be for non-timber forest products like mushrooms. We do kind of we run the gauntlet of different activities that can be used, forest can be used for. And lastly, I'm a land manager, and that kind of takes forestry into all its different uses. There's a lot of social aspect. There's a large social aspect to being a land manager. So I work with people. I do education. I I record everything. At the Game Refuge, we have an all-taxa database, and I've recorded about 1,400 species so far in the past 4 years. And so that's 590 species of plants. And so as a land manager, I'm very interested in all aspects of the forest community. So moving on to the topic of the day, I think it's important to establish what a forest is. It sounds pretty obvious, but bear with me. A tree-dominated ecosystem whose composition is determined by moisture, climate, disturbance, soils, and slope or aspect. And this is general for forests all around the world. All these things influence how a forest grows and the types of trees that grow in it, how old the trees can become. And it's especially true in a place like Connecticut that's basically an accordioned geologic plate where the topography is constantly changing. None of our mountains are big, but we've got lots of hills. And so, every little up and down creates changes in the forest. And I wanted to show you what that looks like in real time. This is a view looking northwest, as you can see the north arrow in the upper right corner. But it's more or less north-south. And what I wanted to show you is just how, going back here, these factors that influence a forest are influencing this picture. So in the center, behind, on the top wording, it says disturbance. And behind it is all that evergreen forest type, and that's all pine, mostly eastern white pine, but there's also some pitch pine. And that's growing in that site because previously that land had been cleared for pasture. And when pasture land is abandoned, oftentimes white pines are the first tree species to grow in. They have very small seeds that are windblown, and they can make it through the grass down to the soil when larger seeded trees can't. So that forest type it arose because of the disturbance. The disturbance was a human-made pasture. Now in the center part, kind of going right across the middle of the photo, you can kind of see the gray-white stems of sycamore trees, mostly sycamores, some sugar maples, but it's a pretty distinct change in the forest, and that's because it's a floodplain of the west branch of the Salmon Brook. And so here we have moisture and soil type that have created the forest. And it's a very rich soil because it's all of the eroded forest materials that come through from West Mountain, but it also has runoff from farm fields as well. So there's a lot of silt and sediment. So it's great for species like sycamore that need that rich, moist soil. And then in the near ground of this, or in the foreground of this photo, is an oak forest. And that oak forest is facing west. And south and west in New England is where trees get the most sunlight. The most sunlight and the most warmth, because the sun rises in the southeast because we're above the equator, shines kind of tangentially on the south and then the southwest. And so, but in the afternoon, the heat is more intense. So trees that can handle warm, dry conditions tend to be on those slopes. And so the aspect of that forest dictates its type. So forests are not just a random assortment of trees. Forests grow in specified areas in specified ways based on species and age. So we understand, and that was a snapshot in time. But forests are also a successional process where along a continuum where trees that begin after a disturbance tend to be trees that need abundant sunlight. They grow quickly. We often call them the live fast, die young trees. And we'll go over those species a little bit. But over time, as those trees grow and die, other trees grow underneath them. But those trees have to be adapted to more shade. And as the forest gets bigger and bigger and bigger, less and less sunlight hits the ground. So over time, the trees that can grow in that forest as it gets old have to be well adapted to shade. So an old forest has a different assemblage of trees than a young forest because of that shade continuum. And disturbances can reset that. So if you can imagine that a forest is 40 years old and then there's a hurricane and wipes it all out, it resets and never goes through that whole spectrum of change. So disturbance is a very important part. And New England forests are heavily disturbance influenced, more so than many other parts of the country. Disturbances here, we have ice storms, we have hurricanes, we occasionally have tornadoes, we have insect outbreaks that are native. Now we have invasive ones as well. Fire used to be a well-used tool in the landscape before Euro-colonial expansion across Connecticut. Native Americans regularly burned the forest for at least 1,500 years, but we suspect much longer. So anyway, there's many ways to understand how a forest develops, but this is one of the most useful tools to get an idea. And in 1996, there's another paper that was published in 87 that's fundamental. In 96, Oliver and Larson from Yale put together this model to describe the New England forest type. And basically the idea is that there's 4 phases. And in the first phase, everyone's on the bus. It's a forest where everything gets started in an open setting. And this was often used for New England because most of our forests began in open farmland. And I have a diagram to show you what that would look like. But as the forest ages, really all those small trees become very competitive for sunlight. And there's not much on the understory. And stem exclusion is really, it's really when the trees are pole sized, anywhere from an inch or 2 wide up to, it depends on the type of tree, but usually around 6 to 8 inches. And the canopy is one level sheet across the forest. There's not many branches down low. It's a whole bunch of poles, and the shade is very dense and uniform, and so there's not much going on underneath. There's not much, maybe some ferns, but there's not a very diverse understory. But as that forest ages, slowly over time, some trees do better, some trees get struck by lightning, little disturbances happen, and over time, the forest kind of creates little gaps. And in those gaps, you get new trees that come in, shrubs. The forest becomes more diverse in the understory reinitiation. And then the last phase is old growth. And generally, old growth is when the new trees that are coming up replace the original trees. So you go essentially through a full cycle of growth, of life to death. And it's one way of understanding the forest. And it's a process-based understanding. And it works really well in New England for the most part. It doesn't work so well on the West Coast for their various forests because their disturbance regimes are different, because they have catastrophic fires even before the climate change. Or they have trees that live for 3,000 years, and it's really hard to create a model when that means there's 3 generations of trees since glaciation. It's really hard to map that out. But going back to what I said before is, I'd like for you to kind of look at the species here, because I suspect some of you are pretty familiar with trees. And if you look, each phase has trees that are most dominant. And in that first stage is the paper birch, the gray birch, black cherries, and then eastern red cedar. These trees all basically need full sunlight or they will just die. And that's why often when you're in the forests of around here that are a bit older, you'll see the dead skeletons of all of these red cedar trees that did grow in full sunlight, but now are just shaded out, and it's so rot resistant that the trees just linger as little statues. But also you'll see tons of paper birch and gray birch trunks on the ground because they'll live for a time and then they can't compete with the other trees and they die off. Stem exclusion is when you start to see oaks and hickories emerge and outpace those really fast initial growers. And you also have white pines. Like I said, depending on the forest type, white pines might be abundant. And then there's a few other species in there. I'm not going to go through every single species, but you kind of get the idea that there's a slight shift where oaks and hickories start to come into the mix, and maybe tulip poplar. And then in the understory reinitiation phase, there's some key things that are starting to happen. Some of the trees that are becoming more dominant are those shade-tolerant trees. They tend to grow slowly, and they tend to be able to grow in very shady conditions. And I really want to point out sugar maple, eastern hemlock, American beech, and black birch. And they are, and so those species usually aren't as abundant in the earlier forests, especially hemlock and sugar maple. And then old growth is when you basically have all those slow-growing trees that are now in the canopy. You know, the aspens are gone, the oaks and hickories are really dwindling if there's any left. You know, there's no cherries, there's no red cedar. And that forest type, an old growth forest, will pretty much keep that type of forest dynamic with those species over a long time. They can self-perpetuate, they can grow in their own shade. And there's just, I want to add an asterisk for two species that break the mold because they live so long. And those are eastern white pines and tulip poplars. And we know from experience across the East Coast, they can live for 400 years. Tulip poplars probably over 500 years. White pines also 500 years, depending on the conditions. So you might get multiple forest generations within that time frame, so they kind of break the mold. And out west, Douglas firs are the same way. They start in an early forest, and I mean, those can live for 1,000 or more years. So, but like I said, disturbance can change that trajectory. And this is an image of a forest operation at the Yale Myers Forest in eastern Connecticut. And this was a forest that was in the understory reinitiation phase, the third phase of development. And the plan here was to remove most of the trees, but to leave a fair number behind that could either be used as ecological reserves or to be harvested later when they've achieved monumental size because they're in full open growing conditions. But what that does is this essentially takes that understory reinitiation stage, and it takes a little wonky because a lot of that becomes a young forest because there's so much sunlight, you get lots of trees coming in, but you get those legacy trees that linger. And so this is what that looks like 3 years later, is where you kind of have this broken forest. Over time, this will end up looking like much more like an old growth forest because it has a diversity of ages and sizes. But if there's no disturbance, no major disturbance, you get old growth based on the model. And that is a forest that, there's essentially little left of the original forest. Maybe there's some white pines and tulip poplars and maybe a couple of oaks, but pretty much it's given way entirely to sugar maple, hemlock, beech, black and yellow birch. And the forest is complex. If you look at this diagram, there's broken trees, there's leaning trees, there's trees, large trees, small trees, medium trees. It's really runs the whole spectrum. And that's created mostly by what we call gap phase dynamics, where lightning strikes, insect outbreaks, trees age, sometimes there's parasitic fungi. They all can cause trees to decline over time, and trees have different levels of resistance to them. Maybe the tree started growing on a site that was just a little too wet for it to be happy, and it made it for 100 years or 150 years, and over time, its roots couldn't develop well enough. So there's some random elements to that as well. But as that happens, you get these huge accumulations of woody debris, and some tree species have wood that really resists rot. White pine is a good one. Oak, especially if they're elevated off the ground. Like, I don't know, you can see my colleague in the photo here, how she's dwarfed by the crown of this tree that came down. And that wood will linger for a very long time. And it also tends to have a lot of standing dead trees. And this is a white pine that presumably died. For a tree to be bleached like this, it's dead for at least a decade. But these standing white pines can last for a long time. And there's a forest in southern New Hampshire that was owned by Harvard University called the Pisgah Forest, or the Pisgah Tract. And it was an old growth, never harvest virgin forest that was hit by the 1938 hurricane. And all the pine trees, it was a pine dominated forest. And today the pine trees are just still on the ground. largely unrotted. Some of them still have some bark. And so some species really can linger. And that has a lot of implications that we'll get into a little bit later, but you understand that dead trees are a part of it. And so if you look at if you want to know what that looks like, the textbook Oliver Larson old growth model, this is pretty much it. This is in Great Mountain Forest, which is in Norfolk, or Falls Village, maybe, Connecticut. I'm not sure exactly where this is within the forest, but in Great Mountain Forest. And it's a little ravine, and on the left side, you can see yellow birch. I don't know if you can see my mouse here. No, you can't. There is yellow birch with this kind of shaggy bark up on the hillside on the left. And in the center, the big straight trees are hemlock trees. And in the bottom and on the right side, you can see the kind of the very vibrantly green leaves of American beech. So the species composition is trees that can really handle a lot of shade. They're large. Hemlocks generally don't lose their branches like this until they're very old because they can tolerate shade, so they leave their branches on for a long time. And you can see there's really diverse plant communities. And in the upper left, you can see a big tree that has fallen over. In the far top left, there's probably much more underneath this growth that we're not seeing in terms of coarse woody debris. And you see there's lots of layers to this forest. So I don't know the age per se, and I don't know if it was ever harvested, but it would not surprise me if this forest were 200 to 300 years old. One of the greatest features of these old growth forests, again, I say old growth because that's the Oliver Larson model, and I'll talk about the terminology more, but the trees are really old and complex. I mean, these are birch trees. The one on the left is a yellow birch tree. And that type of crown is often called stagheading. And that's when the top breaks many times and you get these kind of right angles in the canopy. And so this tree could easily be 3 centuries old. And the one on the right is a sugar maple. And sugar maples tend to grow with a tall straight stem or maybe a couple stems. And you can see here, this is again, a tree that has grown many times and probably broken many times and regrown from the top. And again, very old. And kind of anecdotally, the tree on the right, these are both at the McLean Game Refuge. And the tree on the right is a black bear marking tree. And it is covered for the first 40 feet with black bear claw marks. Absolutely covered. I've never seen anything like it. It makes it very hard to identify the tree when you're up close to it because the bark is so irregular. Old trees, obviously, and the complex canopy structure. And this looks like something out of the tropics with that really, really complex layering effect of trees in an old forest. So I mentioned the term old growth, and I said I've been using it because it's the Oliver Larson word. But I think there's many ways people define old growth, and I like to be careful the way I use it. Oliver Larson uses it as a forest that represents in a complete generational cycle in a forest. Now, a lot of people use old growth to describe a forest that has never been cut, never been burned. Basically, when Euro-colonial arrival in New England happened, from that point till today, nothing has really happened in that forest, and they call it virgin or old growth, and that's pretty universally agreed upon. But it gets a little fuzzy because there's a lot of forests that are really old. I mean, many of you have heard of cathedral pines in Western Connecticut. That grew up after timber harvesting. I don't know if it was after, I don't know if it happened in an old meadow or not. There are species within that forest that make me think that it was not ever converted from forest to another use. However, we know that it began growing in the early 1800s, around then, late 1700s, early 1800s. So the trees are 200, 250 years old. They're very old. But did they meet that threshold for, pre-Euro-colonial disturbance? And so often when we talk about old forests, we put a threshold. I think in the Pacific Northwest, in Washington State, I think they say any forest that's over 180 years is old growth. We don't have anything like that in New England. It's been tried for different reasons, but you can imagine it's very Old growth is a tricky word in it. And so I'm pretty careful, and I like to say old forests. Unless I'm very specific when I say old growth, like I'm using the Oliver Larson model or I'm using the virgin forest model, but old forest works. So that's what we're going to use for the rest of this presentation. But I won't feel bad if you use old growth. Okay, so why do they matter? And that's the big question. Why are we even talking about it? Well, they do something that other forests just can't. And that happens because of their structure, their age, the size of the trees, the way the trees fall on the ground and stop water flow. They create these really, really unique habitats. They have cavities that work for big animals. The way the forest, they serve a variety of ecological purposes. And let me just show you instead of just telling you. First of all, they have large tree cavities. You have to have a large tree to have a large tree cavity. And those are important because we have large animals that nest in trees, or den in trees, I should say. Some of the ones we know about, we know raccoons live in trees, and raccoons are fairly big. I mean, I kind of forget how big they are, but there's one walking across my backyard the other day. It's like half the size of one of these chairs. And so they need large den cavities. And gray foxes. I don't know how many of you are familiar with gray foxes. I'm not particularly familiar because I never see them because they're mostly nocturnal or crepuscular, meaning they're not out during the day and they're very skittish. But they have retractable claws like a cat, and they like to climb up into trees to den. So they need large tree cavities. Black bears will den in tree cavities, and I've seen footage in Great Smoky Mountain National Park where they have filmed families of black bears denning in giant old tulip poplar trees. So we're a little far from that at the moment in our forests of Connecticut, but it's possible. So yes, having large cavities really does make a difference. Also, just the nature of an undisturbed old forest allows for certain species that really, really shy away from the limelight. And this is a hermit thrush. And hermit thrushes are some of the most interior dependent forest species we have. We don't have any obligate old growth species. In the Pacific Northwest, they have the spotted owl, they have the marbled murrelet, they have these birds that only live in old growth forests because of specific needs. But in the East, we don't. But if we were going to pick one, it would be the hermit thrush. And additionally, these old forests allow for the development of really unique microsite plant communities. And you can see this rock is like a little flower pot. There's nothing else below it, but the soil and the conditions of shade and organic debris that have accumulated on this rock have allowed for a really rich, diverse assemblage of plants. One of them is I think it's the purple flowered or the pink flowered raspberry. I can't remember what the common name is, but it's one of our native raspberries, and it actually has a leaf that looks more like a maple than it does the oval shape of a typical raspberry. And we only have found it at the game refuge growing in these really unique sites in the older parts of the forest. Also, the fungal communities that develop in old forests are not like young forests. This is a mushroom that doesn't decompose anything. This mushroom only connects, works symbiotically with trees. So all mushrooms have what are called mycelia, which are little rootlets that reach out. They connect with tree roots and also connect with nutrients. And they reach nutrients and moisture the tree roots can't. And give them, and then shuttle it to the tree, and in return they get sugars from the tree. So the fungal communities and the diversity of fungi is much higher in these forests. Also, old forests create soil. It's not hard to understand that. Organic debris rotting on the forest floor. And this is something that is often overlooked, is that old forests are a genetic storehouse. So if you have a forest with trees that have withstood, we had a little ice age in New England that ended in the mid-1800s. Before that, the winters, the average winter cold was 20 degrees lower. The average winter low was 20 degrees lower. A farmhouse in New England might have burned 30 cords of wood. Really different climatic conditions. So if we have trees that started growing and living in the 1800s and they've made it through today. They've made it through like this unusual climate, cold, to our unusual warm climate today, and have been able to withstand all of it. So if we maintain those trees and let them reseed our forests are going to get the best genetics to carry on into future uncertain conditions. They moderate water, climate, temperature. They slow down the flow of water across the land. They shade brooks and streams. We'll go into this a little bit more. But you get the picture. These forests have huge value for our landscape. Now let's talk about the forest today. This is your average forest in Connecticut. This is a survey statewide done by the Department of Forestry for Connecticut Deep. This is 3 years old. But basically most of our forest is old enough that it's as old as a person. You know, 1 human lifetime or less is an average forest in Connecticut. And it arose following colonial land use. So this is a disturbance. This is the disturbance that started our forests. This is what most of New England looked like. This is a diorama. If you want to see this, this is actually, the background is painted, but everything in the foreground is made by hand, I think in the 20s or 30s. And they're about 5 or 6 feet wide, about 4 feet deep. And there's a series of these dioramas at the Fisher Museum at the Harvard Forest in Petersham, Massachusetts. It's open to the public. It's remarkable. But they retell the history of the New England forest. So this is what it looked like. There's little patches of trees at best, essentially nothing left of the original forests. But fast forward 50 to 100 years, and these farms all were abandoned. Farming became too difficult. There were better job opportunities. Importantly, sheep, which New England was the sheep capital of the world for about 40 years. Sheep left New England for literally greener pastures. And so our forests started to come back. And so today our forests, we have some really great soil. I mean, the Connecticut River Valley, I heard one scientist claim that it was 40% more productive than the best soils of the Ohio Valley. So there's a reason why we're still farming Connecticut's valleys. But even then, a lot of it has been abandoned. And so that's where our forests arose. And today, we're kind of in this second, third phase of forest development. After about 100 years, we start to enter that understory reinitiation phase. And if you want to be reminded what trees, this should sound really familiar to you about if you're someone who walks in the forest. You see a lot of oak trees, a lot of hickory trees. They're very common. White pine trees. You see a variety of birches. You know, you do see hemlocks. You do see sugar maples. You kind of get to see the broadest array of common forest trees right now in Connecticut. And this is what a lot of Connecticut looks like. This is maybe on the older side. This might be 120 years here. But, you know, this is still a forest that still has oaks and tulip poplars and hickories in the canopy. So this is where we are right now. The question is, where are our forests going? Unless we have a major disturbance, it makes sense to assume that they'll all go into old growth based on the Oliver Larson model. You know, more shade tolerant trees. I mean, if you look here, there's a hemlock underneath. And those are black birch trees, which tolerate shade really well. And that's a striped maple in the foreground with the big leaves. I didn't mention them, but they're a very common shrubby tree in old forests. But there is reason for concern. And this is kind of the crux of this discussion, is that if we want to see more of that forest that we saw at Great Mountain Forest, that has those tremendous values, we really need to be careful. And here's some of our threats. Some we can control, some we can't. The first one is climate change. This picture, I know it's a pretty terrible picture. I'm sorry, I don't have a better one. But you can see a lot of brown, is the point of this photo. These are all birch trees dying at the game refuge in this recent drought. And this wasn't a super dry site. This is a very middle of the road type of site. And if you look in the background, the oaks are doing okay. Oaks are those trees that can handle the sun, the warmth. And interestingly, the sugar maples are doing fairly well. So it's hard to know which species are going to do well with climate change, but it seems that black birch and yellow birch are fairly susceptible to climate change, especially drought. So addressing climate change as a whole is important. And I know that sounds very intangible, but it's good to just know that there are consequences in there. We're seeing them right now. And what this means is that as our climate change, we'll have fewer trees to choose from to reforest our landscape in these shady conditions. There's another major threat this is one of actually two different ones. I didn't get into the newest one, but beech trees are more common in southern Connecticut than they are here. But beech trees are suffering from a disease that's been around for about a half a century, I think at this point, called beech bark disease. And basically native and non-native beetles that prey on bark, on beech trees, inject, unknowingly inject fungi into the trees when they bite them. And that fungi decays the tree. It girdles the tree and kills off the living tissue, and the bark cracks like this and they die. This is worse in cool, wet climates. So New Hampshire, Maine, New York, upstate New York, the beech trees look atrocious. Down here, they've been doing so well, but there's even a new pathogen, a nematode of all things, that's getting into the leaves of the beech trees and is causing decline. So that's I just named two species, two of our maybe 4 or 5 old growth species. We have sugar maple, American beech, eastern hemlock, and yellow and black birch. Well, so yellow and black birch are susceptible to climate. Beech is susceptible to beech bark disease. And hemlocks. Tragically, this is one of the largest hemlocks probably in all of southern New England. This was growing at the game refuge. It's over 40 inches wide, so twice as wide as this column. And it died from Hemlock woolly adelgid, which is a pathogen that has arrived in Connecticut in the 80s and in the late 80s. And I'll get into that in a little bit more detail. But that's a problem. And we've had cold winters that's really knocked back the adelgid, which has been really effective. But our winters are getting warmer and warmer, and so the insect is surviving, is having better success reproducing. And drought has weakened, so it's like almost a 1-2 punch between drought and Hemlock woolly adelgid. And there's a third pest called the elongate hemlock scale that's been here since I want to say it was identified in the 50s. It's been here for a long time. And that tends to weaken the trees but not kill them. So hemlocks are having a hard time, but they're much more resilient as a whole than beech trees, which just will die and sucker and die and sucker. They're almost like chestnuts in a lot of ways. But there is hope, and that's why I kind of wanted to end on a high note, is that so the Hemlock woolly adelgid, so there's 3 things that are affecting hemlocks: drought, elongate scale, and woolly adelgid. Hemlocks are pretty resilient if they just only have 2. If we can knock out one of those problems, then our hemlocks may survive. And we can't really do much about climate change. It is what it is. But we do have a new tool for combating woolly adelgid. It's not new, but we haven't been using it very much. There's a predator beetle that eats Hemlock woolly adelgid that's native where Hemlock woolly adelgid is native. And we, as well-meaning conservationists, have really, really messed up by introducing predators to areas to deal with invasives. I mean, there's a list of nightmare decisions that have been made around the world. And so the Connecticut Agricultural Experimental Station, which is based in New Haven, took these beetles and they really tested them very hard at all types of conditions. And they found that there's only one other species of insect that these beetles will eat. And that's the white pine adelgid, which is another pathogen that's a problem. So they literally starved to death before they ate anything else that over decades of research. So for a while now, the Connecticut Agricultural Experimental Station has been releasing these beetles in heavily infested areas with Hemlock woolly adelgid and has seen really promising returns. Trees with just a few gray needles refoliating. And some of it's been done. There was up in Ender State Forest, there was a lot released, and they've been released throughout the state. I think They've released 160,000 beetles, and they reproduce pretty prolifically. And this is what they look like. So you get a colony of 100 or so, and you set them on the tree. And so you can see they're the size of a sesame seed, really. But you clip them to the tree, and they quickly disperse. And what they do is they go up into the canopy. They're very hard to study once they're released. And that's part of the reason why they've been slow for acceptance, is because it's hard to really follow them because they're up 100 feet in the air. But this is a new strategy that has been implemented in the state. The Game Refuge just released a few colonies this fall, and we're working on a large coordinated effort for the Farmington River Valley. So I'm working directly with Carol Chia who's a research scientist from the Agricultural Experimental Station. At the Game Refuge, we hope to release, I think 3,000 was our goal for this year. We're hoping to partner with other organizations because there's some great grant funding opportunities to do this, to save our hemlocks. And one of the things I should say is that we were hesitant at the Game Refuge, but at this point, they're already released. The cat's out of the bag. So you can either decide to use a tool or not, and you may lose your hemlocks. They don't spread very well. They don't spread like across the landscape like the way so many of our invasive insects do. They might hop from tree to tree in an area. And so it might be a while before they actually start saving trees that we care about in areas that haven't had releases. So it's something to really think about. And I really want to highlight why hemlocks are so important. And we're really lucky that we have a solution for hemlocks, because hemlocks, unlike American beech, unlike sugar maples, and unlike the birch trees, they're a keystone species. Now, a keystone species is any species that essentially is the architect of their environment, where if you remove them, the entire ecosystem changes. Now, we only really have two keystone species in the Northeast. One are beavers. Beavers will come into an area and they will completely change everything. They'll change the hydrology, the way groundwater and surface water intermingles. When they cut down all the trees to make a beaver pond and they leave, an entire new forest grows up. With new diverse species, you can have an old growth forest with a whole bunch of birches and aspens that grow up in the middle of it because of beavers. There's countless ways beaver ponds are one of the best places to raise brook trout. Salmon use them extensively. So beavers were really important. Hemlocks are the same way. Hemlocks create the deepest shade, and they can survive in the deepest shade. So they cool our brooks more than any other tree, especially because they cool them in the spring and in the winter and in the fall, when deciduous leaves have fallen. So hemlocks are disproportionately beneficial to cooling our brooks. Here's a headwater stream, and we often think of these as our brook trout streams and cold water, but up in the upper mountains, these are really important. And one species, this is the northern spring salamander. If you're like me, you didn't know this existed here until I just found out a couple of years ago. It's 7 inches long and it's pink, and it's a salamander that lives only in these type of headwater streams. And we found them at the Game Refuge. They're listed in Connecticut as a threatened species. Threatened. There's 3 levels in Connecticut. I think it's the middle level. But brook trout, this is a par trout on the left with its little par marks on its side, and then that's an adult brook trout on the right. Sorry for the poor photo quality. These are brook trout at the Game Refuge so on all levels of the watershed, hemlocks are very important in keeping things cool because these species are dependent on cold water. And I forgot to mention, we just did a botanical study at the Game Refuge, and in one of our mountain streams, we identified a lichen that is so rare, it's only been identified 5 times in all of New England ever. And we believe that it's doing so well because of a hemlock-dominated forest. We're hoping to do more studies on it. The U.S. doesn't really list lichens. Connecticut Deep doesn't list lichens as endangered or threatened, et cetera. But Canada does. And there's the IUCN is a global conservation website, and they're considering listing this species as a red list species. So hemlocks are really invaluable, especially to our area. So I hope that there's some takeaways from this, and that our forests are aging. They're in those kind of middle stages now, and they will push toward that older forest composition as they age. And their ecological value increases so much. Now, as an aside, this is not to say young forest and middle-aged forest isn't important. It's actually invaluable, and if we don't have that, there are other problems we have. Like, we can't have a forest without oak trees here in New England, or we'll lose so many species that are dependent on oak trees specifically. But in terms of the entirety of the ecosystem, old-growth forests are invaluable. But we all have to engage with it. If you're a member of the land trust, if you own land, if you if you volunteer with farms or private organizations, you should know and be aware that it really matters how we manage these things. And leaving it be, we can't do that anymore because we already created the problems. So if we don't deal with the problems, we're going to have things where, we have hemlocks dying. And I'm just picking on hemlocks because there are other problems as well. I mean, dealing with invasive plant species is a whole other issue. But there's hope for the hemlocks. And hopefully, over the next year, we will release a lot of these biocontrol beetles in the game refuge and hopefully in other partner organizations across the Farmington River Valley. And maybe we'll even do it at Belden Forest. And if we do go for a walk today, there's some really great things to see because Belden Forest, quick show of hands, who's walked in Belden Forest before? About half of you, that's pretty good. Well, every time I go there, I'm amazed because there are new things that are worth pointing out. So we can see who's interested in going for a walk. I don't know what the rain is doing right now, but if it's too rainy, we can always schedule a walk for another day. Anyway, thank you so much for listening in on this presentation. I'm happy to answer questions for a little bit if you guys have any. And otherwise, I'll linger and we can chat afterward. But go ahead.
So I have a lot of hemlocks that I've lost over the years because of woolly adulthood, but I can see a bunch that are surviving. They're pretty small. Are they
Yeah.
worth saving by spraying? I've never sprayed for them, but I know there's tree companies that do spray. Is it more harmful to spray?
So the spray is effective. Horticultural spray or horticultural oil or insecticidal soap, there's different iterations of treatment that you can do for individual trees, especially if they're small. And it works really well. And if you have the resources to do it, yeah, you can certainly keep the trees well. Once they get fairly big, I think you can you can get backpacker power or backpack motor powered aerial dispersers that can blow vaporized spray up into trees, but above 30, 40 feet, it's really hard. And so if you have a good group of hemlocks, and they have hemlock woolly adelgid, it makes sense to think about the beetles. And so, and if that's something you're interested in speaking about the beetles, we will be hosting a workshop in January for the surrounding towns. And let me know, and I'll connect you with the agricultural station that coordinates the beetles. So, yeah.
When you say you'll be hosting a lecture, is that you, the McLean Game Refuge, and do you have a website that lists events you have?
Yeah, so yes to your second two questions. Yes, we have a website that lists our events. Yes, we post on it. The best way, if you want to know what's happening with the Game Refuge, is to sign up for our mailing list. And so if you go to there's a contact us page on our website, and you can click, yes, I want to receive information on that. The workshop we're hosting in January is in coordination with the Farmington River Watershed Association and a number of land trusts in the valley. So yes, we'll send information to the Simsbury Land Trust, who will hopefully disseminate it. But if you're on our Game Refuge mailing list, you'll also learn about it there. Yes.
Is the composition of the Ethel Walker Woods comparable to the Game Refuge? In terms of trees?
Yeah, it depends. Parts of the Ethel Walker Woods. Ethel Walker is about 500 acres, so it's kind of like a snapshot of part of the Game Refuge. It's about the 10th of the size. But yeah, the age. I haven't cored trees, but having been there, my estimate is about 100 years, 120, somewhere in there. So it's old. It's definitely in that third phase of development. And the Game Refuge has everything from we cord some trees that we have one ravine where we've cord trees that are over 370 years old. So we kind of run the spectrum at the game refuge, but I think the Ethel Walker Woods and Town Forest and some of these different parts of Simsbury are really good examples of what the older forests around here would look like. But Belden Forest is singular. It has a very different species composition than the game refuge, so it's kind of a unique place. Yes?
Are the beetles that you're releasing for the hemlocks suffer from a very cold winter?
The evidence we have so far suggests that the beetles are not hampered by cold the way the adelgid is. So the beetles seem to be better protected for whatever reason. Probably because they're mobile. The adelgid it has a mobile stage when it's growing, and once it's an adult, it doesn't really move. And so they're really limited to getting out of harsh conditions, whereas the beetles can like snug up right into the bark of the tree and endure the harsher conditions better. And I'd say one of the reasons why the beetles are so effective is that there are other things that eat hemlock woolly adelgid. It's just that hemlock woolly adelgid preys on hemlock in every stage of its life. From its as soon as it hatches, it eats that hemlock. It pierces the phloem of the tree and sucks the nutrients. And all the other predators only eat the larval stage or only eat the adult stage. The beetle we're using now eats the adelgid at every stage of the adelgid's life. So it's like a 1-2 or 1-to-1 correlation, and that's why it's successful. Yes?
This is about other trees, but I've noticed that the trees along, is it 185? There are a lot of trees that are dead that look green, nice and green, because it's all just like smothered in vines. But do you know kind of what's causing that, and what if anything is done about that?
Yes. So I suspect you're talking about ash trees. White ash tree is a very common tree, and you'll notice I didn't really mention it. It's because it's already kind of a done deal. Ash trees they're common like oak trees, similar in size, but they're more abundant on wet areas, whereas oaks are more abundant on dry areas. There's an invasive beetle called the emerald ash borer, which came here from Eurasia, and it was found in the Lake States in 1998, I believe, and has worked its way east. And when I came to the game refuge in 2017, our ash trees were pretty much fine. I mean, maybe one or two ash trees showed some decline. But in the 5 years I've been here, we've gone from essentially fine to I'm shocked every now and then I see some ash trees that look okay. But we expect about 99 to 99.5% mortality. So, yeah, that's what we're seeing. Yes?
So you mentioned that beavers are so important for the environment up here. Do you know why Simsbury removes the beavers? Because they're on Firetown Road up near my neighborhood of Northgate. The beavers have disappeared, and hedgehogs have disappeared.
So the good news is there are beavers right now at that intersection of the Stephen A. Payne and Bisselbrook. They're just further back. So there's actually a beaver pond back in there into the game refuge. And we've been studying bird migrations across that. But yes, beavers are a real pain in the neck if you're worried about infrastructure, because they love to dam up culverts and small dams. And so bless them, the town DPW, it wages continual war with beavers. And the area around Northgate is really low all around, so beavers would have traditionally flooded that area forever. But now there's so much development, the DPW there's no way to really manage them. But in the game refuge, we will not remove beavers unless we have a major conflict with the town that we have to find some resolution for. And we have 1, 2, 3, maybe 4 sites, at least 3, possibly 4 sites where beavers are active at the McLean Game Refuge right now. So
So on Hedgehog, Hedgehog Road the beavers have changed the environment there, but now they're gone completely. Do you know if there are any left there?
I don't, but beavers can occupy an area for up to 40 years and decide to leave, and then they can come back. It really depends on what resources are available. And we've had beavers come to certain parts of the game refuge, set up a dam, looked like they're going to be really active, and then abandoned it after a year. So it really, I don't know more, but if you want to learn more about beavers, there's a wonderful book written recently called Eager, and it's the author's really great. It's an easy read. It's not some heavy science-based reading, but it's so informative. And the person who wrote it is not a wildlife ecologist. He's an environmentalist who is curious about beavers, and he has opened the eyes to the world of the value of beavers. And one interesting fact I'll share is that beavers historically were probably a beaver dam would have been found every mile on every river in Connecticut that beavers could dam up. And beavers can dam a big river. They would have dammed the Farmington. So every mile a beaver dam. So if you can imagine just how many beavers were historically in this landscape, it's pretty astounding.
One last question.
Yeah.
My backyard is McLean's, I live in Hermit.
Mm-hmm.
So, the rock levels are there, and we hear trees now coming down all the time up on the hill. You know what, I don't know whether it's one particular species or just old trees or.
Well, this is something funny I learned when I was a forester is when you spend a lot of time in the woods, you hear a lot of trees coming down. So if you live in the woods, but there are, it depends on where you are. There's a little notch on the north end of that little ridge there by Northgate. And there's a lot of ash trees in there. The tallest ash tree at the game refuge I measured in there. Actually, the tallest red oak and the tallest black oak in Connecticut both live in that notch in the game refuge. So, yes.
The tree that has all the bear markings on it, the claw markings, is that along any trail where we can see it, or is it not?
It's not. It's not. You would never find it. But that doesn't mean that we can't organize a walk. So, if the Simsbury Land Trust wanted me to lead a walk at the game refuge, I would be glad to.
On a non-bear visiting day?
Yes.
I know poison ivy is an issue because it's invasive, but I'm really concerned about that oriental bittersweet that just seems to be enveloping whole areas. And I look at it and I think kudzu.
Yeah.
In the south, and I'm wondering how much worse it's going to get.
Well, the good news is it's not as bad as kudzu. The bad news is it's here to stay, but it's been here for I think it was introduced in like the 30s. It's been here for a long time. I think it was introduced by Arnold Arboretum run by Harvard University. Thank you, Arnold Arboretum, for this wonderful addition. And it was planted to stabilize roadsides, especially during the major highway construction era. And the bittersweet was, and so was kudzu, I think, right? But bittersweet requires sunlight, and so if you go to a lot of these older forests, you won't see bittersweet. So bittersweet is the demon of the forest edge, and the floodplain forests of the Connecticut River Valley. But as forests enter that old growth stage, bittersweet just can't survive. So if you want to manage bittersweet, I know this kind of takes the conversation out of the old forest, but bittersweet, the best way to manage bittersweet is to kill the biggest vines, because you deplete the seed sources. You'll see it on the ground vining, and that's problematic, but they're not reseeding. They're spreading vegetatively by rerooting, and they're limited by how far they can go. But it's the big vines covered in berries that you want to cut. And my advice is, if you find big vines, cut them and use a tiny bit of herbicide, and you just paint the stump, and it will kill everything connected to those same roots. So, yeah, bittersweet's a problem. But again, it's not an old forest problem. It's a forest edge problem.
What are your thoughts on the autumn olive berry?
It tastes great. Yeah, it is really invasive. I actually met a woman at the game refuge who looked at it and she said, "This is from where I grew up." And I was like, "This is not native to Connecticut." She's like, "I grew up in Uzbekistan." I was like, "Oh, of course." So yeah, autumn olive, or sometimes it's called Russian olive. It's not an olive, but it does have olive-like leaves that are kind of leathery. They're silver on the underside. And they grow in pastures and field edges, and they have these really wonderfully scented white flowers. And then right now, they have these kind of pea-sized drupes. Drupes are kind of an oblong berry, and they taste great. Birds love them. They've spread them all over, and they're problematic, but like bittersweet, they don't really invade an interior forest. They need sunlight. Another common invasive that's like this is the multiflora rose. I mean, that's another plant that has really, really wonderfully fragrant flowers. They're really good for wildlife because they're dense thickets that prevent predators from prey, but they're not an old forest problem per se, forest edge problem.
Well, if it's forest edge, it's never gonna get to be old forest if all these invasive things are smothering it, right?
Yes, and I'll say the biggest problem for these invasive species is deer, because deer will preferentially eat the native species that would compete with these invasives. So if you go into a forest and you say, Japanese barberry, multiflora rose, Japanese, oriental bittersweet, or Asiatic bittersweet, I should say, you realize that it's they're doing really well, and there's just no natives competing with it. It's because our deer population is artificially high because we don't have good predators and we don't hunt. And so our forests are suffering. And so to your point, it's really challenging to let those forests break out of that edge dynamic. The best thing you can do is fence it. And as crazy as it sounds, is to fence the deer out. And then you have a chance to decrease the invasives long enough for the natives to start to take over again. So it's a tricky problem. And the deer conundrum is the same from Virginia to probably the New Hampshire border. Hunting's real good up there. Anyway, you guys, I will stick around to ask more questions, but for those folks that want to get up and stretch their legs and head out, go right ahead. And if you are interested in a walk, we can chat afterward. And it sounds like a lot of rain. I don't know what's going on out there, but we can see what's going on. So thank you again for everyone.